You have seen amazing object detection in action, identifying cars, people, animals in real time. But have you ever wondered how AI goes from seeing this to giving us this clean, perfect single box around each object? The secret weapon is an algorithm called non-maximum suppression. And today we are going to demystify it with a simple example. Why do we even need non-max suppression? Well, object detection models like YOLO are designed to be thorough. They predict many bounding boxes, especially when an object falls into multiple grid cells or matches various anchor boxes shapes. For a single car, the model might predict 3, 5 or even 10 boxes, all thinking they have found the same object. If we output all of them, our result would be a messy, unstable blob of rectangles. So NMS is a cleanup mechanism. So what is non-max suppression? It is a post-processing algorithm that intelligently filters out redundant bounding boxes, leaving only the best ones. Here is a quick summary of how this algorithm works. So starting from the step number 1, which is input, we start with our predicted bounding boxes, their confidence scores and an IOU, that is intersection over union threshold. Second step is sorting. All boxes are sorted by their confidence scores from highest to lowest. The next step is to initialize a list with the name keep to store our final selected boxes. Then comes a loop. Pick the box with the highest score, let's call it Bmax, add this to our keep list and remove it from the list of the boxes. For every other remaining box, we calculate its IOU with the Bmax. If the IOU is greater than our IOU threshold, we discard that box because it has a grid overlapping and it is considered as a duplicate of Bmax. We repeat this until no boxes are left. Our keep list contains the final known overlapping detections. Let's apply this algorithm to our car image example. We have 2 cars and 5 initial bounding boxes. Our IO threshold will be 0.5. First we sort them in descending order of their confidence score. So blue box comes first and then yellow, then red, then purple, and in the last we have the green box with the least confidence score. We have initialized a keep list that is currently empty. We select the highest scoring box, that is the blue box, and add it to the keep list and remove it from the previous list. Now we need to compare its IOU with all the remaining boxes. To speed up things, I have pre-calculated the IOU intersection over union values for all possible pairs of our 5 boxes. Remember, IOU measures how much 2 boxes overlap. A value of 1 means perfect overlap and 0 means no overlap. In this table, the first row shows the IOU between the blue box and all other boxes. So we can see that the IOU of blue box and the green box is greater than 0.5. It is 0.8 in this case. So we will discard this box. Now we will again select the highest confidence box from the list and add it to the keep list. This box will be removed from the original list. Now we again compare the IOU with all other remaining boxes. So the IOU with red and purple is greater than 0.5. So these 2 boxes will be discarded as well. And that's it. Our active list is now empty. The non-max suppression algorithm has done its job. Our keep list contains only 2 bounding boxes, the blue box for the big car and the yellow box for the small car. A clean single detection of each object, just like we wanted. Non-max suppression is a crucial step that transforms raw, messy predictions into actionable, clean object detection. It is the silent hero behind many computer vision applications you see every day. If this breakdown helps you understand non-max suppression, please hit the like button, subscribe and let me know in the comments what other computer vision concepts you want me to explain. Thank you for watching. See you in the next video.